We are back. So remember I said, for me, the reason why I download the full GenBank file is so that I can get additional information about the sequence. Okay? So that it's easier for me to say like, okay, I only want sequences that are human. Okay? I only want sequences that are from a given country. Right? Hey. Okay. Finally open this. Like you see, like I have location's name. Because we have the information from GenBank, I can even get the city or the province, which I can't just get with a faster header, correct? But remember, this requires a bit more bioinformatics processing, okay? So I had to use a script that takes in the GenBank file and converts that information to a tabular format, table format, okay? And in this, okay, this one didn't. Here I even have like the sequence length, then I can even filter, for example, these ones that are too short and say like, well, I don't need that or something, and such kinds of information, okay? Now, the other easier way of doing this is using GSAID, right? How many have used GSAID before? How many have GSAID accounts? GSAID. How many are able to log into GSAID? How many are able to log in? Okay. Just a few. So you see, with GSAID, let me just see. So I can decide like I want epipochs and I want data from a very specific clade, let's say clade 2B, and I know ours is like, okay, it's not, so this is what I want you to demonstrate. Like for our data set, it's clade 2B, but there are different clade 2Bs, right? Like they're different lineages, correct? Because if you, I don't know if I still have that. So this is the consensus. You can see that they are all clade 2B, but they're different lineages, right? So ideally, if I could go to here and select clade 2B, but I can't choose all the B lineages at once. So I'll just select 2B. And you can see that we have 10,000 sequences there, right? And here, it's so easy, you can like select the time of connection, right? You can select like, okay, I want to look for things from January 2022, for example, okay? And so I'll just choose first, right? You don't even have to put the end date if you want everything after a given date, but you can also choose the end dates. Alternatively, you can also look for submission dates if that's what you want. Just remember that you understand what the difference between collection and submission is. Okay? I don't know if you can also select the location here if you want. For example, I want sequences from Africa. You can even be specific to the country or even to the province, or depending on which level of information you can get. So GSAID is easier, as you can see, compared to GenBank, right? But not all pathogens are in GSAID. Here we have flu, coronaviruses, RSV, monkeypox, and arboviruses such as dengue, chikungunya, and Zika. So which means, for example, right now we do know there is an outbreak of Oropouche virus, right? We don't have Oropouche virus here. Or if you're working with HIV, you won't get HIV viruses here, right? So yes, GSID is easier, but it doesn't have all pathogens. Secondly, you're not sure like if all the sequences that you have in GenBank are also here in GSID. Because some people, they only submit to GenBank. They don't submit to GSID, right? Okay? So sometimes, myself, I am forced to download both, combine them, then remove duplicates. Okay? So I just want you to understand this process that now you're getting into the weeds of the bioinformatics. It's a long process, but I want you to understand that process, okay? So we've talked about downloading the publicly available genomes. Sometimes you might want to download reads, not assemblies. Reads, fastq. You understand? So we can also use ENA. Okay? ENA is, I find it to be easier. So here you can either search by accession or just text. So I can just look for monkeypox. I'm not getting anything. Interesting. Ah. Okay. That is very interesting. Don't know what's happening. Does anybody have an idea why my search is not working?
Maybe just agree to the bottom, just agree.
Shouldn't affect, but
Still searching.
okay. It was me who was impatient. All right. Okay. So this will still give you assemblies and other things, but often I'm interested like in the reads, so you can look for specific projects, and look for specific samples. Okay. See, you can get a list of all the sequence data, whether they are Oxford Nanopore or Illumina, etc. So this is if you want to run a background data set that is fastq in addition to your own data set. Okay? Good. All right. Let's say we've downloaded our publicly available data. the other thing I want us to do is, often what you will do is concatenate sequences, right? So you have a file with different sequences, you have another file, now you want to join them together. Okay? So, did somebody finish the run? Did you finish? Okay, good. Do you have the file that you ran initially before with the two samples? Is it also there? Good. Now, let's assume we need to concatenate, which means we want to join the two files. So you can use the command line, use the command cat, or you can use copy and paste in an editor, which can work, but can also be problematic. But because we want to be bioinformaticians, I'm going to encourage that we use cat. Okay? So let's assume that we have
Can you increase the font?
Yep. Just a second. Now let's assume that I have two files. And one, I'll just don't do what I'm doing. So let's say I have two FASTA files, run 1 and run 2, right? And I want to join them together. So you can easily use cat, yeah, run 1, run 2, and then I can easily use that redirect to point it to my new file. So I can say all runs with fast. So all you need is say I want to concatenate all the files into this file. Okay? And I'll hit enter. Sometimes you're in a directory where all the files you want to join together are called something.fasta, right? So let's say I want to join all the files that have a suffix or an extension called .fasta. What do I do? I say cat, all the files that have the name .fasta, star, .faste, and then I give it a name, right? Okay? Can you tell me why this second option can be a very dangerous thing? Because you see, let's say I had run this before, right? And now what it has done in this second line, it has joined this file, and this file, right? So we are going to have lots of duplicates in there, right? So be sure that you know about what you're doing when you use the wildcard. Okay? Fine. So we've concatenated our files. Now we want to start getting to the tree. The first thing is we need to do an alignment. Okay? So to do an alignment, you start with sequences that look like this. They are not aligned, right? I know our case is slightly different because we did reference-based alignment. And because we did reference-based alignment, our sequences look like they're already aligned, which is different. I need you to be aware of it. Because remember, when you do a reference-based alignment, you're using a reference, you're mapping all the reads to that reference, and any position that is not in your sample will be filled with an N. Then you end up with a sequence that looks like this. If I can just find my consensus. So your sequence, if you use a reference-based alignment, it will look like this. So they always don't look like this, right? But you can see that for these two sequences at the bottom, you know, it will tell you clearly that this multi-faster file is not aligned, right? So we want to align this file. Okay? So I'll go back here to my slide sets. So you can either do an alignment with a reference or alignment without reference, which means you're aligning the sequences against themselves. And obviously, we talked about selecting the right reference genome. Okay, it's very important to be selecting the right or the appropriate reference genome. And most often, you want the earliest sequence. Okay, so if you're analyzing clade 1B, you want to take the earliest clade 1B that you know of, right? So there are a couple of options. We have a tool that we call MAFT. So with MAFT, you can install it in your command line, use it, but there's also a MAFT server which you can drag and drop your sequences and align them. Okay? But remember, this is a server. Somebody is offering a service. There's always limitation on the number of sequences that you can analyze, and you don't know how long it will take. Okay? But I'll send Christy the URL so that you can just be aware of this. Okie dokes. There you go. So here you just need to like upload your sequence and then it will do the alignment for you. Okay? So I'll give you an example here. So I can give the MAFT server. I don't need to change anything, and then I'll just submit. However, we want to use the MAFT that is available on the command line. So we want to install MAFT using Conda. This is simple. So can you install MAFT on your environments, which you should have received on Slack and WhatsApp? I think it should be Conda install MyoConda. Would you use the C option or?
I also put it in your Slack. You should have the same messages.
So there are different ways you could do this. You could do that, or you could go the option where you specify the channel.
Arnold, do you want to jump in here?
Oh.
James, give yourself a breather. Do you want to
Yes.
something?
Please.
So do you want them to create it in a new environment?
No, they can just use the same environment. Yeah. The next one. Maybe, to be honest, I'm really not obsessed about environments. Not install MAFT. Kina pa install MAFT. All right. So we've installed MAFT. You can see on the, if if I just zoom this on the mapped server, I gave it a set of sequences, and it's even telling me the command that it has used to do the alignment. Okay? All right, so we are going to do our own alignments on the command line. So as always, you can do mapped help to give you, a bit more information about how to run mapped. Okay. Are we there? So you can see it's telling you the mapped version that you're running. Again, remember this is very important. When you're writing your paper, if you do your analysis, you need to state the version of the tool that you're using. Okay? Is that clear? So always note the version of the tool that you're using. Very important. Okay? All right, good. So here it's saying that mapped is as simple as running mapped, and then your input tree, you direct it to an output file. Okay? And here they say, which is something I like very much, if you're unsure which option to use, are we there? So what I want us to use a simpler method now. In alignments, there are very many parameters that you use. But I don't want to go through all that now. We are going to use the simplest way of doing this. So I want you to call mapped, and then use the auto option, and then your input file, which is the consensus file that you got from your Epi2Me run. Then put the redirect symbol, and then give it a name. You remember how I was naming my files? So you pick a way to name your file so that you know what your output file name is. I repeat. So, and go back again. We've installed mapped, right? We have sequences that are not aligned. We want to align them. So, good practice, if a tool is new to you, always use the tool name and help, correct? So I did mapped help. And I get this information here, as well as how to use mapped, correct? When you are writing your paper or analysis, always include the version of the tool that you're using. Okay? So that if somebody was to do the analysis again, they can be able to get the same results. Because sometimes the results might change if you use a different version of the tool. Okay? So always note the version of the tool that you're using. So for example, if you're writing a report, you'll say, I aligned my sequences using mapped version 7.525. Okay? Now, here it's saying there are different options of running mapped. We are going to use this option. Mapped, auto, name of file, this, name of output.
That option, if I'm unsure, which option to use, that's all. You are unsure what.
So, a tool has very many options. As you can see here, for example, there's something we call gap opening penalty. So gap opening penalty comes along when I wanted to avoid this, but so let's assume we have two sequences. I'm just going to name them ATGC. Sample 1. Sample 2, it's called A. Okay, let me. Sample 2, we have AT. Okay? Then we want to align these two sequences, right? So we have probably that go to A, T, G, C, A, T. When we start with this can go here, A, align with that. This T, align with that. And then this A, you have to look for where to align it. Okay? So maybe, we put a gap there, then an A there, then a T. Now, in doing alignments, you always have to score them. Okay? Because initially you're doing pairwise alignments. In the end, you're scoring like, okay, there's a score for a match, there's a score for a mismatch, and there's a score for a gap. So, and even the first gap might not necessarily have the same score as the second gap. So that's why on the options, you'll see something called the gap opening penalty. I mean, I'm not going to go into the details. That's what I was trying to say. If you're not aware of most of those options, what they mean, a tool might give you the simplest way of being able to do your analysis, correct? So this is what Maft is doing. By saying that so because I don't know what gap penalty is, right? I don't know what offset is, okay? I'm just going to use auto, which means that the tool is going to decide based on the data the best parameters or options to use.
Bon, ce qu'elle d'expliquer en fait, c'est l'outil MAFT. L'outil MAFT, c'est un outil pour faire l'alignement. Vous vous rappelez, depuis le premier jour, on avait les fastq, on a fait la contrôle de qualité et on a généré avec Epi2Me, qu'est-ce qu'on nous a donné? On nous a donné le consensus. Et le consensus là, maintenant, il n'est pas aligné. Il a expliqué que, heureusement, nous, comme il y avait la référence, c'est comme si c'est aligné, mais ce n'est pas vraiment aligné. Donc, pour cela, il faut l'aligner. Pour l'aligner, il y a un outil qui s'appelle MAFT. Et le MAFT, là, on a téléchargé maintenant en utilisant avec Conda. Maintenant, on l'a. Maintenant, il faut, cette fois-ci, il faut maintenant l'exécuter. Pour l'exécuter, il y a des options. Et des fois, tu ne connais pas ce que cette option veut dire. Il y a ça, il y a ça, il y a ça. Et pour voir ça, comme on nous a montré, tu mets l'outil help. Comme ça, tu vas voir l'architecture de la commande. C'est MAFT avec. Il y a des options, vous explique. Si tu ne comprends pas, tu vas utiliser l'option auto. Donc, tu mets le nom de la commande MAFT, il y a auto, et il y a in input. Ça veut dire quoi? C'est le fichier maintenant qui contient les consensus. Celui qui contient les consensus. Quand quand vous avez lancé Epi2Me, dans les résultats, il y a un fichier qui finit par fastq. Si vous l'ouvrez, vous allez voir qu'il y a beaucoup de séquences dedans. Donc c'est celui-là que vous allez mettre dans là où il y a une in, vous mettez ce fichier-là. Et après, il y a, c'est marqué out. Out, ça veut dire quoi? C'est la sortie, mais ce n'est pas le dossier. C'est comment le dossier, le fichier est aligné, comment il va être appelé. Donc là, vous allez mettre un nom que vous voulez. Alors, quand l'outil map va finir, le fichier qu'il va générer, il va le nommer comme vous avez voulu faire. Le autoraro, ça veut dire quoi? Il va prendre les options, il va choisir le meilleur pour vous. Ce n'est pas vous qui allez choisir, vous avez pas dit. C'est bon?
Donc, généralement, il faut regarder d'où on est parti. On est parti de nos fichiers fastq, c'est-à-dire nos échantillons. Et ces échantillons-là, qu'est-ce qu'on a fait? On a fait du contrôle qualité, on a fait toutes les étapes et on a obtenu nos fichiers de consensus. Ce sont des fichiers généralement FASTA. Maintenant, ces fichiers FASTA, pour pouvoir construire un arbre, il faut faire de l'alignement. Et l'alignement, c'est quoi? L'alignement, c'est la mise en commun des bases pour avoir quelque chose où il y a des matchs, des bouts. Et pour avoir un alignement, il y a plusieurs types d'alignements. Il y a des alignements 2 à 2 de séquences, et il y a des alignements multiples. Ça va. Et ici, l'alignement qui est fait, comme on a plusieurs séquences, ce sera un alignement multiple. Et l'alignement multiple se fait avec plusieurs options. Ces options-là, c'est soit insérer des gaps, soit insérer, il y a plusieurs options pour faire l'alignement multiple. Et comme nous, on ne veut pas manipuler chacune des options, on va dire, utiliser un outil qui va faire l'alignement pour nous. Cet outil-là s'appelle MAF. Et on va lui dire, pour les options d'alignement, toi-même, il faut choisir les meilleures options. C'est pour ça qu'on met auto. Maintenant, il va faire quoi? MAF va faire quoi? On met l'option auto pour lui dire de choisir les meilleures options. Donc, il va faire les alignements sur quoi? Sur le fichier où il y a tous nos alignements. Donc, il va utiliser quoi? Nos fichiers où il y a quoi? Il y a tous nos fichiers FASTA. Et quand il a fini de faire l'alignement, qu'est-ce qu'on souhaite? On veut le résultat de l'alignement. Donc, on fait un signe supérieur et on le met dans le in. C'est nos fichiers où il y a toutes nos séquences. Le out, ce sera la sortie de l'alignement. Le tiret auto, au tiret auto, ça lui dit de choisir les meilleures options d'alignement pour nous. Yeah. Is it clear? Good? Very good. Okay. So, in my case, I'm using math, auto, and my file name from Epi2Me is this, and I'm calling it, you can see I've added this bit to my file name so that I will know that this file and then I'm adding this bit of information to differentiate it from this sequence that this one is aligned. Remember, do not give the same name as my file name. Okay? Stanislas, can you tell them not to run my exact command? Like, use your file name. Don't use my file name. Use your file name. S'il vous plaît. Math-out. Après, c'est quoi? C'est le in, n'est-ce pas? Le in, lui, sur sa machine, le in s'appelle ça. Voici son in. C'est à moi. Ça, c'est ce qu'il a donné comme nom à sa sortie Epi2Me, où il y a toutes ces séquences. Maintenant, vous, sur votre machine, comment est-ce que ce fichier-là s'appelle? C'est ce que vous devez mettre ici. Maintenant, la sortie, c'est à vous de donner un nom. Par exemple, lui, pour pouvoir reconnaître des fichiers d'alignement chez lui, qu'est-ce qu'il ajoute? No, I just want to show them something quickly. when you are running your Epi2Me, what did you put here? Okay? If you put test run like me, my output is called test run dot all consensus dot faster. Okay? If you put your name, maybe, if you put maybe run one, okay, your output will be run one dot all consensus dot faster. So that's what I'm saying. Don't copy mine. Use yours, whatever you named your file.
Et puis après, vous donnez un nom de sortie. Vous pouvez prendre le même nom et à la place du all mettre quoi? En ligne pour dire c'est le fichier d'habitant.
So, again, I'm insisting, by informatics, you have to understand the context. Don't just copy the commands.
So because from our output, when you look at it, you have two sums, you have 80%. When you look at the QC, CSP, you have like these two sums. So I think they
Good points. You mean this?
There's that one that ends with 89.
Yes. These two, correct?
There's one even with 58, that is 847. That's number
58.
For me, I have one which is that ends with 847.
Oh, yeah.
There is one with 38%, that is 880.
All right. Are we running maths? I was already in my output directory. So if you're in a different directory, remember about the paths. Okay? So be sure that you specify the path if you're not in that directory where your file is. We started with our fastq, right?
Yes.
Then we made a consensus file. In this case, we did not get background data, but I'm just showing you common practice, right? You can get some background data from GenBank or GSAID, and then you join them, catenate, okay? Into consensus plus background data, okay? Then we run math. We have consensus
Plus.
okay, yeah, for consistency. Let me just say here background here. It's not too long. So then we have consensus plus background but aligned, okay? And then after we come from lunch, we are now going to use IQ3 to now give us a phylogenetic tree file. Then once we get the phylogenetic tree file, we are going to visualize it using different tools, and we'll see our phylogenetic tree. Okay? So this is just to give you the general workflow of what you'll be doing. Okay? Remember, yesterday we said this is an iterative process. You might generate a tree, and then you don't like it, you start again. For example, in your Epi2Me run, there was a file called qc.csv, right? Did you see that file? And that file gives you information on each of these sequences. For example, here we have the %n. You remember we were talking about the quality of your assembly and where we were looking at the %n. So for example, this sequence here has 96% n. Monkeypox has 200,000 bases, right? But we are only able to assemble 583. That's very bad, right? For now, I've included this in our alignment, and we are going to make a tree. I want to see how that looks, okay? Then, but normal practice, you might even remove this before you do your alignment, okay? But I just let it now proceed to the end, okay? So, this is an iterative process. You might generate a tree, you come back and say like, okay, I want to remove this one because it is very low quality. And also maybe this one. And also maybe this one. Okay? And then generate the alignment again. Or sometimes you don't need to generate the alignment again. You just need to, I don't want to confuse you. You might just go back to this file and remove those sequences only. Then you proceed. So, Conseil, Stanislas.
Ok. Donc, ce qu'on en fait, on vous a expliqué hier, que construire un arbre phylogénétique, c'est un processus itératif. C'est la première chose. Deuxième chose, vous avez besoin de séquences de bonne qualité. Donc, ce qu'on sommes en train de faire, c'est qu'on va générer un arbre avec toutes les étapes. Donc, on va passer fichier consensus, on va utiliser des fichiers d'airbag, des fichiers de contexte. On va concaténer pour avoir nos consensus plus notre fichier de concept. On va faire l'alignement. On va construire un premier arbre, on va le visualiser. Maintenant, quand vous allez regarder dans vos séquences, vous allez vous rendre compte que les séquences sont de mauvaise qualité. Généralement, ces séquences-là ne doivent pas participer à l'alignement. Donc, qu'est-ce qu'on va faire? On va essayer de repérer ces séquences-là, retourner dans le consensus, supprimer les séquences qui ne nous intéressent pas, reconstruire notre consensus, refaire l'alignement et construire l'arbre jusqu'à ce qu'on obtienne quelque chose qui tient la route. Oui, bien sûr. Oui, il faut que tu saches que c'est un processus itératif.
Yes. No. If it was a bad job, it's a bad job. Hey, Ella, you remember this one? Let me remind you, because you might have forgotten. Where is my file? Go for lunch. Let me. Christy is sending you a link on Slack and WhatsApp.
No, I'm putting it in the Google Doc.
Okay, on the Google Doc. Okay, I have to browse this.
I've copied it into the Google Doc. So.
Okay, here.
It's there.
got some small crack in the database which we can run later today. Okay? So I want you to run this command, wget. Oh,
I'm just making the column wording.
okay. Wget space tire c. That tire is hyphen. Right? So hyphen C and then put that link and download that as you go for lunch. So just leave it to download.
Ok. Il faut, vous allez utiliser wget. Vous partez sur ce lien-là, vous avez accès. Vous faites wget et vous téléchargez. Vous allez faire un téléchargement. Ça va prendre du temps, au retour on va l'utiliser, mais il faut le lancer avant de partir.
Just run it and leave it like on your terminal. And when you hit enter, then you just hit enter and then leave. Then we go for lunch. We'll come back, find it finished. Just saying 10 hours.
Who's getting an error?
No, sir.
James, someone's getting an error.
Somebody's getting an error.
Yeah, let's try and address that before they go for lunch. Otherwise, they're going to